Passport is the most popular Node.js authentication library out there. It is well known by the community and successfully used in many production applications. Passport has a rich ecosystem of strategies that implement various authentication mechanisms. While simple in concept, the set of Passport strategies you choose from is large and presents a lot of variety. Passport abstracts these varied steps into a standard pattern, and the Nest.js Passport module wraps and standardizes this pattern into familiar Nest constructs. So far, throughout this entire course extension, we have implemented everything by ourselves without using Passport, just to show you that even though Passport is great to use and super popular, you can build a fully fledged, flexible authentication system without using it as well. In this lesson, we'll show you how you could integrate Passport with Nest, which might be useful for situations where you don't need that absolute full control like all of the custom things we've done throughout this course. Also, just to mix things up a little bit more, instead of using JWT for authentication, we'll be using server-side sessions, which is another great option for authentication that may make sense in some applications and circumstances. A session allows web apps to persist data about the current user between requests. The mechanism we use to accomplish this is a cookie, which allows the server to create small blocks of contextual data placed in the user's browser or device. So what that means in the big picture is that when a user logs in, we generate a session ID and send it back to the user, expecting that it will be sent back to us in subsequent requests as a cookie. On the API side, we can then compare the received ID, aka session ID, with the ID we have stored in memory. The issue with this approach is that it's fully stateful. If you have a load balancer in front of your API, the user may authenticate through the first instance or node and then access resources through another instance. In this case, the server won't recognize the user. To solve this problem, we typically use a database for storing session IDs, most often Redis. Alright, so before we start, let's open up our terminals and install a few dependencies: Passport, Nest.js Passport, and Express Session. Let's also install their corresponding type definitions, but make sure we save them as dev dependencies. Once the installation process is complete, let's open up our env file and add a new environment variable for our session secret. We need a secret to encrypt and decrypt our session IDs. Next up, let's open up our IAM module file and add two imports for Express Session and Passport. With those in place, let's scroll down to our IAM module class and make it implement the Nest module interface. This interface requires us to provide a consumer method that takes one input argument, middleware consumer, which lets us register middleware functions. Here, let's register a few Passport-related middleware functions. Note that the order in which middleware is placed is very important, as they get ran one after another. With our middleware functions registered, let's open up our terminals and generate a new session authentication service using the Nest.js CLI. We could have instead modified the existing authentication service that currently implements JWT-based authentication, but since we don't want to confuse you and mix these two concepts, we're deciding to keep them separate. Next, let's generate a dedicated session authentication controller. Great. With both files in place, let's navigate to our session authentication service and start by injecting two providers into the constructor: user repository and our hashing service. Now, in this service, we'll implement just one method, sign-in, which will actually look just like our sign-in method in our authentication service we created a while back. So let's go ahead and copy that method over and replace a few things. Let's start by removing the two-factor authentication code here, just to make the authentication flow easier to comprehend. And instead of generating tokens upon successful login, let's just return the user entity. The code here can be found below the course video, as always. Next up, let's move on to our session authentication controller class. First, let's decorate it with the auth decorator, passing in auth type none to make sure all routes declared here in this controller are public. Next, let's inject the session authentication service using the standard approach. And lastly, let's add a sign-in method that once again will be similar to our sign-in method from our previous authentication controller. One difference here is that we're going to use the request login method provided by Passport, passing the user entity as an input argument, which will log this specific user in. You may have noticed that we are using Promisify here as well, as the original login method implements a callback style, and Promisify helps convert callback APIs into a promise. Passport's request login method requires us to provide logic for serializing the user and deserializing it. So let's get that logic set up, open up our terminals, and generate a new class with the Nest.js CLI called User Serializer, and put it within a new Serializers folder, where we can place all of our related logic. Let's navigate to this newly generated class and make it extend the Passport Serializer class from the Nest.js/Passport package. Inside this class, let's declare two methods. Serialize user, which takes the user entity object that we pass into the request login method and maps it to the active user data payload we've seen in previous lessons. The deserialize user method here simply passes the deserialized payload up. Note that we could possibly use the user repository here to retrieve the user entity based on the active user data. But since this method is executed on every request, this would most certainly have performance implications, so be mindful of doing something like that in the future. Now let's save our changes, open up our terminals, and generate one remaining class, a session guard. Once created, let's navigate to this class and add the following lines to our canActivate method, where all we need to do is grab the current request and return request.isAuthenticated method result from Passport, which returns a boolean letting us know whether the current user is authenticated or not. Nice and simple, right? With everything we've done so far, our session-based authentication is now fully functioning. So, to test everything out, let's switch to our session authentication controller and add a random route there for demonstration purposes and protect it with our new session guard. Now, let's make sure to save our changes, and before we test our endpoints, let's make sure we register our user serializer as a provider. Let's navigate to our IAM module real quick, add the user serializer class to the providers array, and save our changes. Great. Now let's head over to Insomnia and start by calling the session-authentication/signin post endpoint, making sure to pass in our credentials in the request body, just like we do with JWT-based authentication. As we can see, we received a 200 OK, so everything worked and we were able to sign in and have a session created. Great. Now if we click on the Cookies tab, we'll see our session ID in there. Now, let's hit our random endpoint protected by our session guard that should say hello followed by our user email, if everything works properly and we're authenticated. And voila, as we can see, we got a 200 OK and we're able to see hello user1@nestjs.com, which is our current email that we signed into our system. Fantastic. As we mentioned at the beginning of this lesson, session IDs are kept in memory. So in real-world systems, we typically use an external database to keep track of sessions. Another important problem to remember is that every time you reboot your API, meaning stop or start it, push to new changes or anything like that, all sessions will be lost and everyone will be logged out. For demonstration purposes, we'll use Redis as it's pretty simple to set up, plus we already have it configured in our application since we used Redis for refresh tokens in previous lessons. But you could use any database of your choice to store session data. Redis is fantastic as it's very lightweight and extremely fast, so it's without a doubt an excellent option for this. So first, let's install a few required dependencies that we will need before going forward: connect-redis and the type definitions for it. Once the installation process is complete, let's navigate to our IAM module file, scroll to the top, and add the following import, importing star as create Redis store from connect-redis. Next, onto the configure method. Here, let's create a Redis store class, passing down the session package reference as an input parameter. And next, Let's update the configuration we passed to our session middleware, adding one additional property called store. And let's make sure to import Redis here from IO Redis. And that's it. In a few steps, we just leveled up our session authentication system to use Redis. Everything should work just the same, but now if we stop and restart our application, we'll see that we are still in fact logged in and able to hit that guarded endpoint we created. For fun, look into your Redis database and you'll even be able to see the key values for your sessions inside. So we've gone through a lot in this lesson, showcasing just how easy it is to use Passport. Passport does give away some of our control since we don't have absolute manual control over every little thing in the authentication process of our applications, but it does make a lot of things easier for us. Note that using Passport with JWTs is very similar to what we've done here. We won't be showcasing that in this course, but if you're interested in that specifically, we cover it in great detail in the official Nest.js documentations. You can find a link to that below the course video. Thanks again for watching.